great architectures have one thing in common. They're simple. And this is a perfect example. This is Roman Aqueduct. It stands for 2,000 years, and it had one purpose, to move water out of the city to the city. And do you know what's the greatest mechanism used for this piece of architecture? It's gravity, right? So it's so simple, yet it still stands. My name is Grzegorz Rożniecki, and I today will be talking about simplicity. And together with Talos Linux, Omni, and Akamai Cloud, I will show you how to help you to simplify your life. And I'm a senior engineering manager, so my story is that, I used to be a software engineer. Right now, I don't have hands-on experience, but 3 years ago, Akamai bought Linode, which is a cloud company, and now it's Akamai Cloud. So 2.5 years ago, my teams started to use our Kubernetes, and I thought, let's just try to do something. And I figured, okay, I will do home lab. And then this is how I figured this would look like. Obviously, this is AI generated, so it's not how it looks like. This is currently how it looks like, because I'm building a house. So in reality, I do have a flat, and this is how it looks like, the working one, right? So this is very simple. There is much more hardware in the back that's not used yet because of the time. And in my case, the main constraint is that I don't have time. In your case, when you are working, your main constraint is like your team's capacity. As a manager, this is the term that you maybe don't like to hear if you are not a manager. But the reality is that at the end of the day, our teams are nowadays struggling with complicated stuff, right? And as it was said, Kubernetes is not simple. Actually, simple, the word simple is the opposite of complex. And simple comes from Latin, which stands for one-fold. It's like one string. Complex means that some intertwining is happening, right? And this is how I found Talos Linux. It's the Kubernetes operating system. What it means? So it means that it has very simple architecture. Its architecture is, the point is to install Kubernetes, period, like with the Roman Aqueduct. And why Talos? So basically it has a good abstractions, and good architecture is about abstractions that just work. This is a quote from Grzegorz Rożniecki. He's an architect who wrote a few books. And this is another perfect example of a classic architecture that has good abstractions. Actually, it's a modular one. And it's the one that we have most likely in most of our homes, especially if you have kids, like Lego bricks, right? So these are like 6-ton Lego bricks, but the concept is the same. When you have the good, small, simple architecture of a piece that is very composable, you can build great things that last forever. And Talos Linux is basically the system without SSH. It's a Linux distribution without SSH. So who knows Talos Linux here? Okay, I see like a few people. For those who don't know, they may be wondering, you may be wondering, so how do you manage this system? So you manage it via API. The only purpose of the system is to install kernel, few extensions, which are actually the way to modularize the system. So there is this plugin, let's say, architecture. But the system is managed by API. What it means also is that there are no users. So there are no passwords to leak. There is no etcd passwd that you can look and try to do something with that, right? There is just less. And more or less, because there are no users and there is API, there is no shell. So if you can imagine any CVEs that your company maybe struggled in the recent years for SSH or shell, they are not there. So by having this simple architecture, they also have an immutable structure, and they provide only 50 binaries total. Like not only 50, less than 50. They are saying less than 50 because they used to have like 12 binaries in a Linux system, right? So what does it mean? Let me just try to show you in practice, and we'll try to. So I was supposed to bring you my home lab via Tilescale, but something doesn't work, so I will use Akamai Cloud. This is Linode, and this is the simple Talos cluster. It has 3 control planes. Oh, sorry. Oh, that's That's the problem that I have. Oh yeah, here. Okay. Okay, so maybe not the best way. So I will just use the slides, okay? But this is the Akamai Cloud interface, and on this interface you can see that there is Talos cluster, and the point is, and I will try to. Okay, I will not mirror things because it will I would spend more time. So this is the Talos cluster, which is installed by hand. There is instruction on the web page of Talos how to install it using this link. Okay, there is this Akamai Talos Linux instruction page there, and you can go there and see how to install using CLI. You can also use Terraform. You can use you can click, and because of the split screen, I will just go back to slides. Let me just go that. Once I find one cursor, okay. All right. And on top of the Talos Linux, there is this another set of abstractions that you can use, which is Omni. Omni is basically managing the Kubernetes infrastructure. So you have a few clusters, and you can manage them in a way that it's very, very user-friendly. You can use UI, and UI provides you a view in all your clusters. In each cluster, there is a view for a machine. After the talk, you can go and we can see on the computer how it works in practice. And you can go use YAML files to declare your manifests and use the Omni declaratively to create clusters. You can use it to upgrade a Kubernetes version of on a cluster. This is like a view of my home lab cluster, and these machines, the three Dell machines that were that I showed you, are visible here. So we can just, by using one click, or again, deploying one manifest, committing one manifest, you can upgrade Talos version, upgrade Kubernetes version, and you can use simple CLI tool, like similar to kubectl or kubectl, however you pronounce it. There is Talos CTL and Omni CTL, which provide you interfaces to interact with Talos and Omni. And they use certificates, so there are no passwords. And to authenticate to this UI, for example, you have to use some kind of a OIDC provider or some provider. There are some instructions to self-host it. So if you want to test it, Talos is open source, fully open source. Omni has a business source license, so for a business use it's paid, but if for home use or testing purposes it's free. You can self-host it. There are some instructions there. And what it means, what it meant for me is that I remember that we started using Kubernetes. I just wanted to experiment with Kubernetes on my machines. At the same time, I didn't want to spend more time with dealing with I'm not a certified Kubernetes administrator. Some of you maybe are. Even some people in Akamai stand booth here today are Kubernetes administrators, but this is a different side. I wanted to see like a developing on Kubernetes. How can I do this without worrying and spending time on the management side, okay? So that's why I think the point here is to focus, to find your focus. So if I want to try to set up Kubernetes from scratch, there is great tutorial for that, and I haven't done it, so just coming clean. But if you just want to experiment with your home lab and don't use any cloud, that's fine, because this also simulates this edge computing, right? So you will be simulating an edge computing in your cluster in home that you can combine. And actually, I had an example of how to combine the, let's say, cloud, do a hybrid cluster, right? So there is a cloud control plane nodes, and there are a few worker nodes. You can label them on cloud, but you can also add your home lab or your machines to the cluster, or you can create separate clusters, whatever, and manage them by Omni. So for me, it was very, very interesting tool that I wanted to share with you. And the point is that you and your teams, actually, you should choose your battles, so to speak, right? Because what you want to do is to focus on what problems do you want to solve. Do you want to fight with, creating Kubernetes clusters from scratch instead of just doing the product that you were supposed to do on top of Kubernetes? Maybe yes, maybe not. But if you don't, you can offload this complexity to some tool or solution. Like here, you can offload this to using Omni for managing clusters in a simple way. Even you can use Omni UI, basically. You can just create an image, upload the image, and then use an UI. And I would say that the complexity, which is, again, the opposite of simplicity, is the main hidden tags, I would say, of the modern software engineering in a sense. It's like there is this term, cognitive load, which nowadays, if you are developing something on Kubernetes, your teams may struggle with having to know exactly everything. Like there is CI/CD pipelines and the stack that I have to maintain. There is Kubernetes that I have to create. Maybe there is some application on top of Kubernetes that I want to manage and I have to troubleshoot, right? And for this, there is this cognitive overload that happens very a lot. And that's why I believe that there are a few people here, I discussed some things with with you already, that are doing so-called platform engineering, right? So platform engineering concept basically is that you are offloading some of this cognitive load by creating the right abstractions. Like previously we saw the like the Lego brick in the pyramid. You are creating the right abstractions and you allow people to create anything from them. And you can create pyramid, but you can create from the Lego bricks, you can create anything, right? If the interfaces are right and the abstractions are right, the complexity is smaller. At the same time, if you just build the basis for anyone, like from this Lego bricks metaphor, and let the development teams use some simpler interface, like, I don't know, only a set of YAML files, with a few lines of code, and they will not be dealing with the stuff like how to manage the secrets and create secrets for your Kubernetes cluster and maybe some database and how to store them and how to rotate them. And that's exactly what, for example, we did at Akamai. So my teams, and again, some of the team members are here, we did this kind of a platform on top of our Kubernetes. On top of our managed Kubernetes, we created some kind of a platform just to offload the 4, now 8 development teams from some burden to reduce their cognitive load. And this is like similar to what I did here. Oh, this is the better photo of how messy it is. And you just don't want to, fool yourselves. In your work, there are some messes like here as well, right? And some messes are meant for you to be fixed, and some messes are not meant for you to be fixed. You just want to offload them to somebody to reduce your team's cognitive load, right? And how can Akamai bridge that gap that you may have? So you may use, for example, as I showed you, some kind of a cloud provider. Obviously, I will vote for Linode / Akamai Cloud because that's where I work for. But if you want a simple cloud, compared to AWS, Linode has only a few services, which can be a bad thing if you want any sophisticated stuff. But if you just want to start simple, like Talos Linux, they started with 12 binaries. They are now adding more. They are now adding more capabilities to the Talos Linux. They are adding more capabilities to Omni. You can do some more, let's say, fringe stuff. At the same time, the core is very simple. The abstractions are very simple. And as long as the pieces match together, they work together, you can build some great things. Like you can build bridges like the Golden Gate Bridge, which also is based on gravity, I would say, similarly to, it's a magnificent piece of engineering. It has almost 100 years. It still stands and it is a landmark. But the concepts, it's a piece of engineering that you don't really see at the first glance. It looks very simple, right? And that's the point. And there is this quote that's attributed to Albert Einstein, which is, everything should be made as simple as possible, but not simpler. It's a simplification of a longer quote that was paraphrased, but the point is still here that you want to make things as simple as possible, but don't overcommit to the simplicity. And using Akamai, this is our current mission, let's say, to empower you to build powerful and distributed applications in a simple and on a simple and scalable cloud platform. And the point of Akamai is that we started with, let's say, Linode, which had this kind of a core and distributed sites, regions. This is more or less the same as you can see in the other cloud providers. But the true strength of Akamai is that we can combine this with our Edge platform, which is also the same which is Akamai Cloud provides you the Edge platform, which you can have much more distributed use cases, right? It's for you if you need that. Obviously, maybe you don't. You don't also need to have home lab to learn Kubernetes, right? But if you want to have some more distributed distributed deployments, distributed computing, then you should at least look at the Akamai Cloud. And that's everything from me. Thank you.